Hello, I'm Lucy Kershaw. I'm an MR physicist here in Edinburgh, and I wanted to tell you about a project that I've been involved in recently. So I was in my office one day doing some important science when the phone rang. And it was my friend John from the vet school. That's the man, not the horse. And he said, "Lucy, I want to image your horse's heart." And I said, He said, "Don't worry, it's in a pot." So I thought, oh, well, that might be all right. He said, but the pot is really very big. And what he actually wanted to know about was the way that the muscle fibres are arranged in the heart. So when the heart contracts, it doesn't do it like this. It's more of a wringing out, like a wringing out a dishcloth. And in a human, the way that it does this is by the top and the bottom twisting in opposite directions. But in a horse, how that happens is that the top stays relatively still and it's the bottom that twists loads to make the twist. So he thought that we might be able to investigate this by using diffusion tensor imaging, which relies on the water molecules that we see in MRI being able to diffuse more easily down the muscle fibres than across them. And we can make the image sensitive to this so that we can tell the directions of the muscle fibres in the tissue. The problem with this is that it is big. A horse's heart is really, really big. So a human heart is around about the size of my teacup, whereas a horse's heart is more like the size of a bucket. And so once this is inside a container as well, it barely fits in the scanner. Here's a picture of the heart in its bucket with some measurements so you can see quite how big it is. So my first attempts were not at all impressive. The container was not round and the heart was completely black, so I was getting absolutely no information about the muscle fibres at all. So I called John. I said, "John, I'm the worst MR physicist ever." And he said, "I'll send you some cake." So he did. And I asked for some help from some people who know a lot more about diffusion imaging than I do, and things got better. So here's one of my later attempts. So now the pot is round again and the heart is grey rather than black, so we're getting some information about that. So with a lot more trial and error, we realised that we needed to image for about 6 hours, and we started to get some really nice pictures of how the muscle fibres are arranged, and this is going to help us to eventually answer the question. So the moral of this story is that science proceeds by little tiny steps and you have to persevere, and it's really important to ask for help because it's all about collaboration, and then also a little bit of cake really doesn't do any harm.